Right, welcome to MCR day 22, unit 4, introduction to sets and logic. So again, welcome to unit 4, made it through finance. So what we're going to be talking about today is the idea of set basics. So going over a little bit of information. So the first one would be kind of what is the idea of a set. So a set might look like this, have some brackets, and it might have some numbers. It might have some letters, or it might have letters and numbers. It could also have words in it. It can have all different things. So the definition of a set is that it's a collection of objects. The objects, again, could be majors, words, letters, numbers, and those different objects are considered members or elements. So especially highlight the word element here, because that's going to be one of our vocab words. It's going to come up a good amount. So our vocab in here is the word set. It's a collection of objects, and those objects are called elements. When we have a set, we list them in these curly brackets, which is what I had up here. Sets are generally referred to with capital letters, and then you would write what's in the set. So a couple examples would be, we could have A be the numbers 1 to 5. So in brackets, it would be 1, 2, 3, 4, 5. The elements of A would be 1, 2, 3, 4, and 5. So we would say that 4 is an element of A. 2 is an element of A. What that symbol is this little E that's kind of stretched. That says that 3 is in the set A, or 3 is an element of A. Now, if you look at A, it has the numbers 1, 2, 3, 4, 5. So if we ask, is 15 an element, you would put a slash through the symbol. 15 is not an element of A. Same way we have equals and not equals. You could be an element of, and then if you're not, you put the slash through. So kind of understand those symbols, write them down somewhere. And as a note, when you're listing a set, elements are only listed once, even if they happen multiple times, and order doesn't matter. So say I was just saying, what are the majors of the students taking this class? And I put those into it. Say someone is in nursing, someone is in IT, someone's in general studies, and we said, what are the majors of the students in your class? You wouldn't list nursing, 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 nursing. You just say it once, nursing, IT, and general studies. But if I flip these around, it doesn't change that those are the majors in the class. So your order doesn't matter, only list your elements once. So for a few practice problems here, we're going to look at our basics and say, are they an element or not? So this is saying, look at set A. Is 10 an element of A? Is 19 an element of A? Spend about a minute. Let's try this one. Okay, so when I'm looking through 10, I do not see 10 in this set. It looks like it's just odd numbers. So I would say false. When I'm looking for 19, 19 is right there. So I would say true. And again, that symbol means is an element of. The set A contains it. Now for V, it's the vowels A, E, I, O, U. So think quickly. Give this about 35 seconds. And you would say, is A an element of V? Yes, it's right there. Is Z an element of V? No, there's no Z. So that one would be a false. All right, so then moving downward, we've got 3 ways that we can write those sets. I'm gonna grab a highlighter real quick to highlight these. So you've got what's called roster form, and that's where you're actually listing elements as words, such as majors or such as fruits. So we would say let B be a set of citrus fruits. So B contains oranges, lemons, limes. We would physically list them out. That's a roster form. We could do something called set builder notation. And that's where you might say C is the set of months that begin with J. We could list those. But we could also write them in what's called set builder. And then I'm going to highlight this one. We could also put them in words. The set of all students in MCR 4, the set of all majors. So I'm going to come back to set builder real quick. When you write set builder, you write the variable such that, and then you define the variable. So it might be months that begin with letter J, or it could be X is greater than or equal to 2. That's your set builder notation. So in this case, if X is all the months that begin with letter J, January, June, and July are all included. And then words would be the set of months that begins with the letter J, the set of all students in MCR 4. All right, so moving along, we've got a couple more vocab words here. All right, so within, we have our different set types. You can also have what's called an empty or null set, which means there's no elements in the set. And you can either represent it with this empty bracket or with the 0 with the slash through it. So if it's let D be the set of names of dogs that are in the classroom, and we have no dogs in the classroom. So we would represent it with the empty set. So where this might happen is if you have sets that come in that have something in common. A, for example, is 1, 3, 5, 7, 9. That's odd numbers. B is 2, 4, 6, 8. Those are all even numbers. So when I say, what do they have in common? It would either be an empty set or the null set. Either one, they're the same, they're interchangeable because they don't have anything in common. So that would be a representation of that. Right. Then we've got an idea of subsets, and think of what that word means, subsets. So they're smaller sets out of a bigger set. So if B is going to be a subset of A, then B can only use elements from A. To be a proper subset, it can't contain all the elements of A, but to be a regular subset, it really can. So this is a little bit misleading here. It can contain all the elements. It's just not a proper subset. So how we use this is B is a subset of A or equal to A. If it's a proper subset, then we say B is basically less than A. So what that means is that B is not equal to A. Kind of think of this in math terms. If you say 2 is less than or equal to 2, that's this first one. So it can include it. But if we say 2 is less than, let's include the 2. So that's the idea here. A subset can only have elements from A. A proper can't be the same, meaning one of them needs to be missing. So down here under these examples, let A be the set of all the numbers from 15 to 25. So 15, 16, 17, all the way to 25, for example. And then we have over here, B is all the even numbers. So each element of B is included in A, therefore B is less than or equal to A. It's also a proper subset, so you could say proper subset. So you could say both. So down here, how I know that it's a subset, I'm going to go 16, 18, 20, 22, 24. Since every single element was there, I know it's a subset. And then down here, C is the set of even and odds from 20 to 25. If we compare it to A, it's the same, so we would put the equal sign under it. Okay, so take a minute to kind of figure out these. Are they true or false? Here's our sets. Is B a subset of A? Is it a proper subset of A? And so forth. So take about a minute here. I'm going to pause so you can look these over. Okay, so in order for B to be less than or equal to A, let's see, A is all the odds, B is 5, 13, 15, and 19. So this one is true, and it's also a proper because it didn't include them all. All right, in order for C, let's take a look, 1, 3, 5, 7, that matches A exactly. So think of this as less than or equal to, it's equal, but it's not less than, so that part's a false. And then for D, let's see what's going on with D. D is 1, 2, 3, 4, 5. So if you notice, this 2 is not an A at all, so it's neither. If you have an extra element there, it can't be a subset or a proper subset. It's just a different set. Okay. As we keep going, we've got some formulas we want to look at. Given a set that say it's S and it has n elements, then there are 2 to the n total number of different possible subsets, which include the original set and the empty set. So if S is dog, cat, bird, then the number of elements equals 3. So you have 2 cubed or 8 possible subsets there. And the idea that the empty set is in there is because you could always choose none. This could be the question of, we're going to a pet store. They have a dog, a cat, and a bird. Do you want the dog? Yes or no. Do you want the cat? Yes or no. The bird? Yes or no. You could always choose no, no, no. You could choose yes, yes, yes. Or you could choose any combination, which would give you the subsets. You could just do the dog, just the cat, just the bird, dog, cat, dog, bird, dog, cat, bird, or none, giving you 8 total. Now, if you want proper subsets don't include the original set. So proper subsets is 2 to the n minus 1. So the 2 formulas to know: 2 to the n for subsets, 2 to the n minus 1 for proper subsets. So make sure you have that memorized. You do not want to have 16 elements and try to be figuring out the number of subsets. And again, it's raised to the power, not multiplied. So let's go back to our V, which was A, E, I, O, U. And can you figure out the number of subsets and the number of possible subsets there? So to do this, V has 1, 2, 3, 4, 5. 5 elements in it. So the number of total subsets is 2 to the 5, which is 32. And the number of proper is 2 to the 5, then minus 1, which is 31. So it should always be 1 less. So if you accidentally put it up in there and get 2 to the 4th, which is 16, it is not correct. It's just 2 to the 5th, enter minus 1. Follow your order of operations there. All right, so if we look at sets on a number line, the idea here. So when I'm looking at a set in set builder notation, but has this mathematical piece, say for example, X is greater than 1. What I do is put an open dot here saying it doesn't include it, and then shade. And that's another representation of saying that that's the set C. Whoops. So if I come down here and look at this next piece, it says that, and I can quickly do a number line here to kind of show what they'd have in common. So I'm going to look at set L. X has to be greater than or equal to 3 and less than, oh, sorry, not equal, it's just less than -5. But the word here is and. There is no number greater than 3 and less than -5. So in this case, L is actually an empty set. There's nothing in L, it's empty, because there are no numbers that are included in both. So a number line is just a quick way, especially if you're being asked what they have in common, to just quickly show, oh, you know what, they don't have anything in common. All right, and like I said, this is set basics. So this is a lot of vocab, a lot of just going over a lot of pieces. When you get to your 154, it'll be the same idea, but hopefully you'll have seen them now so you can take that in. So next we have the idea of a universal set and a complementary set. So a universal set is every element in whatever you're discussing. So if the universal set is even numbers, or the universal set is the numbers 1 to 20, the idea of a complement is that A might be some subset, and AC is the complement, meaning it's all the sets in the universal set, not in A. So I'm going to do an example to explain what I mean. So if universal set U is 1 through 10, A is 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. Then the other pieces would be a complement, 2, 4, 6, 8, 10. So a complement would be all the other ones that are not included. Another way to think about it would be if I have a Venn diagram. This is my universal set. If this is A, everything not in A is a complement. So try question 7. Figure out B complement and C complement for this problem. And I'm going to give you just a minute to do that. So when I'm trying to find B complement, I'm going to go B is 2, 4, 6, 8, 10. I'm going to highlight those. Everything I didn't highlight represents the complement. So B complement is 1, 3, 5, 7, 9. So basically all the odds because B was the evens. So now I'm going to delete that out. Get rid of that one. And look at C complement. So for C complement, C is 1, 2. Okay, let me start getting rid of those. 1, 2, 5, 6, 8, 9. So the numbers I did not highlight are C complement, which are 3, 4, 7, 10. And that gives me my C complement. Okay, then for question 8, it says U is the set of all the letters in the alphabet. So U is A, B, C, all the way to Z. If C is the consonants, think about what's left without having to write it all out. C complement would be the vowels. So you wouldn't always have to write all the pieces out. But if you've already got the consonants, then what's left would be your vowels. All right, couple more items on this intro. Moving down. So then our final vocab word for this day is, oh, it keeps disappearing on me, doesn't it? Is cardinality. So the cardinality is the number of elements in A, or whatever one it's asking you for. And it's denoted by NA or bar A. So if A is the numbers 1 through 5, and you're asked for N of A, it's 1, 2, 3, 4, 5. There's physically 5 elements there. If you're asked for the cardinality of B, and B is the citrus fruits below, 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. So it really is that simple, as long as you remember the notation. So if you're asked for NB, you're being asked the cardinality. All right, last question now is the quick cardinality of AB, A complement and C, B complement. So go ahead and pause, try these, and then come back when you're ready. So the cardinality of A is physically the number in A. There's 10. The cardinality of B is 1, 2, 3, 4, 5, 6, 7. All right, so for A complement, you could do it a couple ways. You could actually write what A complement is. Or you could see if there's 10 in A and 20 in U, then the other 10 have to be what's in A complement. Same for B complement. There's 20 in U, there's 7 in B, so there's 13 in B complement. Okay. So that's what I have written down here. All right, you do have a day 22 assignment, so you will want to work on that and turn it in, and have a wonderful day.